We'll talk about the Upstream Allwinner ARM support system on a chip. So, Hans, ladies and gentlemen, give him a warm hand of applause.
Good afternoon, everyone. Well, my name is Hans Goede. I work for Red Hat as a software engineer. In my spare time, I work on small ARM boards like this one, which are using SOCs from Allwinner. Allwinner is a Chinese SOC vendor who has a pretty significant market share. I think it's something like 40% or something. Because if you count all the really cheap Android tablets which they sell, then you get a lot of devices. And I've been working on taking their Android bootloader code, which is a proprietary bootloader, and their kernel code and cleaning it up and putting it in the Upstream U-boot and kernel so that we can run standard distributions on it. You think my mic is not working? Okay. So can everyone hear me, or do I need to speak up louder? A little bit louder? Okay. So well, let's get started then. Oh, this is interesting. Anyway, Allwinner makes a number of SOCs. The one which made them famous is the A10. This is the one they started with, and they all of a sudden cornered a large piece of the market because they managed to integrate so much stuff into the SOC that a large number of companies in the Chinese Schengen district went bankrupt. Because everything all of a sudden was part of the SOC, so they no longer needed all these separate add-on SOCs for a number of things. The A10 has a Cortex A8. One of the nice things about the A10, which also made it popular under hobbyists, besides that Allwinner is reasonably open, they're not fully open, reasonably open, is that it has a SATA port. So you get native SATA from the chip, you don't need a USB to SATA converter. Then they did the A13, which is a stripped down version of the A10. We will see that they have a tree version of pretty much everything, which is a stripped down version, which is meant for cheaper devices. If we move on to the A20, that boosted the Ethernet to gigabit Ethernet, because it also has integrated Ethernet, and went to a dual core CPU. Then we get the cheap dual core, then we get a quad core. The first quad core was a bit of a mistake, from my point of view, because they switched to PowerVR graphics. And we're working on reverse engineering the Mali 400 GPU. And PowerVR is sort of a no-go when it comes to reverse engineering because it's such a complicated beast that it's really not doable. Then they did a cheap version of the A7, which I have in a tablet with me over here, the A33, which is what I'm working on currently. This tablet, 7-inch tablet, 1024, 600 resolution, not all that great, but a half a gig of RAM, quad core, costs $40, including shipping. Which is what makes an Allwinner device interesting. Especially if you can run stock Linux on this. This will pretty much, if you install latest U-boot, latest kernel, will run the latest Debian or Fedora out of the box. So for $40 you get a nice machine, including a touchscreen and everything. So this gives you an overview of the available chips. They also have an octa-core version out now. What I forgot to tell you beforehand is that Dimitri scheduled me for an hour, but I'm not going to fill an hour. So what's the status with U-boot? I gave this same talk at FOSDEM. This is slightly updated, which is why the first column is February 2014, because that was FOSDEM about a year ago. We are slightly past current FOSDEM now, so I updated the right column a bit. So about a year ago, there was no upstream U-boot support for Allwinner SOCs at all. Right now we have it. In the fork, because there was a fork of U-boot which had support, there was only support for the first 2 generations. Right now we also have support for all the quad cores. A80 support, so the octa cores, is work in progress. PSCI may be interesting for those of you who are into virtualization. The Cortex A7, which is used in the A20 and newer, has hardware virtualization support. So the CPU in the SoC can do basically KVM, QEMU KVM. But you need a bit of firmware support. So the firmware needs some support to be able to use that. U-boot has that currently only for the A20. We need to add this for the other ones, for the A23, A31, A33. And then you can basically run QEMU KVM on an ARM board. So you can buy this little board, which is the Orange Pi, which is like $35, gigs of RAM, dual core. Uses no power, you can power it from a USB port. And well, then you can run virtual machines on a little ARM board for very low power, if you're interested in that. We added video output support to U-boot, which is very important, otherwise you wouldn't be watching this demonstration. Because to give you an idea where we are with the status, this is running on a Fedora 22 installation from an SD card, which is running on this computer. This little bit is the computer, which has an A10 SOC. And we of course have added support for booting from SATA. Some people ask a lot about questions about that. Can I boot from a hard disk? Yes and no. U-boot can boot from a hard disk, but the boot ROM, which is part of the SOC, cannot boot from a hard disk. So you always need like a 512 MB or however small you can get SD card to put U-boot on there, and then you can boot everything else from the hard disk. So how does the upstream kernel status look? In February 2014, Maxime Ripart from Free Electron, if you know the company, they do a lot of embedded work in the open source world, had added basic support, which meant we could boot a kernel and we could communicate with the kernel via a serial port. We had no storage, you needed to load a RAM disk and that was your file system, but we had very basic support. Right now we have support for all the other SOCs, including the A80. We don't have a bootloader yet for the octa-core, but we have a kernel for the octa-core, so if we use the proprietary bootloader we can get the kernel running. We added support for networking, USB, SATA, infrared receiver. This little board also has an infrared receiver, so you can also do stuff with infrared. Yeah, lots of stuff basically. And important, we added support for the MMC controller, so SD cards, so we can now have a root file system on an SD card. And which means that in Fedora 21 and Debian 8 you can just download their ARM images, install the right U-boot flavor, which is part of the images, but you need to install it because it's board specific. And basically everything just works with a stock Linux distro. And of course, very important, on the kernel side we got Simple FB working. Simple FB is a firmware based frame buffer, so it uses the frame buffer as set up by U-boot. So as I said before, because we added support for LCD displays and HDMI out to U-boot, we can now also get a frame buffer in the kernel because it just takes over the frame buffer as set up by U-boot. What's the plan? What are we going to do next year or so? First, let me tell a little bit about adding support for a new SOC. If we want to support a new SOC like the A80, the octa-core, we need to do a number of things. First of all, we need to get U-boot itself going. But U-boot usually is loaded to DRAM, so to the half gig or about gig of RAM which the board has. Well, DRAM needs to be set up too. What we do is the bootloader process is a two-step process. First, the boot ROM inside the SOC loads 32K of code from a magic offset of the SD card, loads that into internal SRAM, and that starts executing. And that needs to set up the DRAM, and then that same code needs to load the real U-boot binary into DRAM and execute from DRAM. What we do is we use stage 0, so the setting up of the DRAM controller and the PMIC, the power management IC, so setting voltages for the DRAM and stuff, from the proprietary bootloader, and we start with getting our own U-boot binary working. Then we only have half of it, and basically we start with the second stage, because that's easiest, and once we have that going, we need to figure out how to set up the clocks, how to program the power management IC, which we can start doing from the second stage. And then eventually we need to get DRAM support working, and then we're pretty much there. Then it's adding nice to haves like Ethernet, USB, video out, all nice to have. Who needs video output? So for A33, we've just gone through all these steps. And currently in my personal Git repo in the SOC whip branch, people may have seen me working on this here at this conference. I made a slide saying that it worked, but it didn't work actually when I made the slide. But now it works. I fixed it yesterday, I think. So we can now boot the quad-core $40 tablet and it will run Linux. I don't need this one. This is my battery pack, in case people are wondering what the laptop's doing. It's a bit heavy for a battery pack, but the octa-core support. Step 1 is complete. We can in my personal Git repo there is a support for the octa-core in U-boot to do the U-boot binary, so the second stage, but we do not have support for the PMIC yet and for the DRAM controller, and that's going to be a lot of work, and I'm not sure who's going to do it. because I'm probably not going to do it because very little people actually buy an AAD device because they're expensive. The AAD is quite expensive. It's like $150 for a device, which is not that expensive if you compare it to other tablets. But for Allwinner, it's expensive. So people were actually actively asking for A33 support. I don't know anyone who really wants AAD support. Yeah, maybe a few QB Board 4 owners. But hopefully, if they're motivated, they'll do it themselves. A83 is the budget version of the octa-core. It's coming. Allwinner is talking to us as in the open source community. They are going to send boards to a number of people who are working in the Linux SOC community. And they are also working on getting the docs ready for publishing. Allwinner now is pretty open. They have a GitHub account. They publish their bootloader code under GPL. On the GitHub account, they publish datasheets on their GitHub account. So soon we should be getting a code drop and documents for the A83. And then we'll see from there. The kernel roadmap. About to release in a week or so 4.0 kernel, we have CPU frequency scaling, so we can throttle the CPU down. For the classic models, the A10, A13, A20 is the classic family, sort of the first generation. We have PS2 support because the A10, when Allwinner did that, I said they integrated a lot of stuff. Basically, they bought a number of IP licenses from companies like Designware and Mentor Graphics, and they just did copy-paste of silicon blocks onto the SOC. It has a PATA controller, so old parallel ATA or IDE. It has a PS2 controller. Someone has actually written a driver for the PS2 controller for some reason, so we have that now. We did some work on adding support for variants of the quad cores and ER receiver support for them. Quite important for the octa-core support, we added MMC support, so now you can have a root file system somewhere else than in a RAM disk. And something called tablet key support. They have some special thingy in there to do things like hardware volume up-down buttons and stuff, and we support that now. And we did a driver for the PMIC. PMIC stands for, I've used the term already a couple, stands for Power Management IC. It's a separate IC from the SOC, which makes a number of voltages for things like analog components, the voltage for the CPU core, the voltage for the DRAM, etc. It has a number of DC-DC converters and a number of LDOs, which are all configurable through I2C. And we need to support that both at the U-boot level and the kernel level. At the U-boot, kernel level, we need it for the CPU frequency scaling, and in U-boot, we need it just to be able to boot. Because without DRAM voltage, the DRAM doesn't work all that well. So for 4.1, we're going to do SMP support for the A23. We already support the A23 with only one core. So in 4.1, we'll be able to also start up the second core, and you get twice the horsepower. For the A31, so the full featured, not the cut down version of the quad core, we'll get power management and CPU frequency scaling. And for the A80, for the octa cores, we'll get USB support, USB host support. Coming real soon now. This code is in my personal Git repo. Maybe for USB OTG support. So playing, that's important for two things. This will allow us to play a USB device. So if you hook up your phone to your computer, it will show up as a USB mass storage device. That's OTG. It will also allow us on tablets, which usually only have a OTG connector, so the micro USB connector, to use it as host. So you can now hook up a keyboard to the tablet and use it that way, because tablets unfortunately are not really usable under Linux without a keyboard. What we're also getting, which is also interesting for tablets, but also for these kinds of boards, I know some people use these to use it as a squeeze box player, so as a music player. We're getting audio support in the Upstream kernel. And then we can actually play audio. There is a branch which has some NAND support. So far I've always talked about SD cards. A lot of the devices, especially the tablets, have roll NAND. Unfortunately they don't use an eMMC. If they use an eMMC it will just work. An embedded SD card basically. But a lot of them use roll NAND. And the kernel has a subsystem called the MTD, Memory Technology Devices subsystem, which was developed a while back to work with roll NAND. But most roll NAND back then was all SLC, single level cell. All the roll NAND used in these tablets, cheap tablets, is MLC, multi-level cell, and the MTD subsystem needs some work to make that to work. We have a branch which has that, which works. The problem is that no one is currently really actively maintaining the MTD subsystem. So we don't have any maintainer to merge our patches. So that's sort of, what it mostly just needs is someone to push this forward. Right, if you push it forward and you push hard enough, then you will just become the maintainer usually, or something like that. Well, I mean, we can fix this if someone puts his shoulder on it. We're also working on hardware crypto engine support. The A20 and newer have a hardware crypto engine, so they can do DES, at least in hardware, and things like that. We have a patch set for that, which is almost ready. So hopefully soon we'll get that too. As I said, I wouldn't be filling the hour, so... Are there any questions about this? No questions? Let me showcase this one. This is an interesting one. Oh, yeah, go ahead.
There has been some discussion regarding video encoding or decoding support on the Allwinner SOC, because that has been published finally blocked with embedded VR.
Yeah, well...
Is there any documentation regarding this block?
We already reverse engineered. There are demos at different conferences. There have been demos of full open source hardware decoding of the Big Bunny movie and things like that in full HD. And it's already completely reverse engineered. And Allwinner indeed is probably violating the GPO and how they're publishing it, but they're working on trying to get a clean code base out. Allwinner was really trying to clean up their act. They recently released a lot of code for the NAND support, because the NAND used also to be in a blob, which we also already figured out how to do it without their help. But so yeah, it's not really that big a deal, if I'm honest. The CDAR, it's called CDAR, the hardware encoding decoding video unit, is already fully reverse engineered. We know all the registers. We can already play video. So yeah, it's mostly just one person who likes to make a lot of noise, and Phoronix picking up the noise that one person is making, because Phoronix likes noise. Yeah, so that's not really an issue, actually. Any more questions? So if you want to play with one of these devices and you want something which more or less just works, this tablet is called the UTO, UTOO P66. You can buy it for $35. It's a single core tablet with half a gig of RAM. It has a number of interesting features. It has an IPS screen. Look, you have a decent viewing angles. Everything works. The Wi-Fi works, the touchscreen works, everything just works. It has an eMMC, no roll NAND, so you can also just put your Linux installation on the flash inside, and that works too. So pretty much you can run Linux on this, except for the GPU. Everything else is supported. Well, thanks for your time. If there are no more questions, and the next presenter can come forward.